Thank you. Yeah, there we are. My name is Wouter Spaak. I'm a senior developer at the Dutch National Police. And we, as well as I assume many of you, found out that managing state is hard. You start out with a small application and then all of a sudden you've got hundreds of routes, thousands of services, all keeping track of their own individual little pieces of state, and you've got to call an update function every time inputs change, and well, it's horrible. So there are a few options to mitigate that risk and mental overhead. And one of the best ways to do that is the design paradigm sort of coined by Facebook called Redux, where you have one point of truth in your application, a store, which has an immutable data store, and every other bit stuff in your application is something that derives from that. But at the police, we have a large problem where our data structure is highly dynamic. And we don't know at the start of runtime what the shape of this store will be. So NGRX, while it's a great library, was out of the question. Also, there's a lot of boilerplate and endless amount of switch statements for actions. And it's not really pretty, but it works. And it works quite well, but not well enough for us. So we need a way to to make it possible to, at runtime, create new origin points for the truth. And there is a library called MobX, which sort of does this, but MobX overrides by default the getters and setters of an object, and then automatically when you just assign a new value to a property, it runs through a dependency graph and updates all the dependencies. And that's a problem because we also use quite a lot of native proxies. I don't know if anyone here has ever used a native proxy, but essentially it's a wrapper for the getters and setters of an object, so you can call other functions that handle the state of your object. So these two problems combined made us look at another solution, and we found a solution in a library called Derivable.js by a very talented engineer called David Sheldrick, I think. But that's written in JavaScript, it doesn't have typings, and also it has one fundamental problem in that it doesn't allow cyclic dependencies. So if one piece of state updates, then the whole directed acyclic graph has to update. But what if that graph updates another value in the parent tree? Then you get in an infinite loop, and well, that's an issue. The browser crashes, and well, that's that. So we designed a library we call Sherlock, because we work at the police, and it's sort of like deriving a truth from a couple of clues. And Sherlock works as follows. There are two components. They're called atoms and derivations. Atoms are ground pieces of truth, and they can be formed anywhere by an atom factory or whatever. And they can be literals, they can be object primitives, they can be immutable values. The Immutable.js library by Facebook is brilliant. Absolutely use it. But then you need to get to where you want to be. So if you've got in the upper right corner of your screen like an avatar, and maybe the first name of the user, you need to get the signed-in user, but you need to derive some state from that, like only give me the avatar URL and his first name. Well, that is what our library does. And where does Angular fit into this? Well, we also made some extensions for Angular for this library. Essentially, a modification of the async pipe by the Angular core team, which when you pipe a promise or an observable into that, tags the change detector to mark for checks. Well, we also do that when one of these derivations changes value. So, oh, I'm out of time. So that's, in a nutshell, our Sherlock library and also the Angular extensions, which, well, will be open source somewhere in the beginning of next week, I think. And I had some code demos, but, well, not nearly enough time, so I'll be around. And if you want to see an Angular app that uses this, please, well, talk to me. Thank you.